Okay, today we're starting chapter 8, and I have split section 1 into part A and part B, mainly because there's a ton of vocabulary and just kind of like nitty-gritty stuff to go over before we start doing operations with polynomials, like adding, subtracting, multiplying, dividing, factoring, all that good stuff. So I just want to make sure that we all have a really good grasp of the vocabulary before we kind of move on to the operations. Okay, first up, a monomial is a number, a variable, or the product of a number and a variable, or of a number and one or more, let's just say or, with whole number exponents. The degree of the monomial is the sum of the exponents of the variables in the monomial. And the degree of a non-zero constant term is 0. So, and then the constant 0 doesn't have a degree. Okay. Lots of new words. So let's talk about, first of all, what is a monomial, right? It could be a number. The number 10 is a monomial. And its degree would be 0 because the degree of a monomial is the sum of the exponents of the variables. Does this have any variables? No. So it has a degree of 0. A monomial could be a number, a variable, or the product of a number and a variable. So this is a product. This is 3 times x. So this is a monomial. And its degree would be 1 because the degree is the sum of the exponents of the variable. This exponent is 1. That's the only exponent that I have. It's the only variable that I have, so it's just 1. Okay, 1/2 AB squared. That is a monomial. It's the product of a number and one or more variables, and that's a whole number exponent, right? With whole number exponents. So the degree of this one would be 3. Because remember a, it's like having a to the first power. So you're not concerned with the numbers. But the variables, we have a to the first, b to the second, 1 plus 2 is 3. Okay, negative 1.8 m to the 5th. That is a monomial. It is a number multiplied by a variable with a whole number exponent. So the degree of this one would be 5 because it only has one variable and that has an exponent of 5. So let's talk about some things that are not a monomial. Okay, not a monomial would be 5 plus x. Okay, it has to be a product of a number and a variable. So a sum is not a monomial. I cannot talk and spell at the same time. Okay, this is a sum. A sum is not a monomial. It has to be the product. Okay, let's talk about this one, right? What would be wrong with this? Okay, well, this is not a monomial because a monomial cannot have a variable in the denominator. Okay, a monomial cannot have a variable in the denominator. And kind of the technical reason for that, let's think about what we just learned with exponents, right? If it's in the denominator, another way to write this would be 2n to the negative 1. And it tells you, right, because remember negative 1, you'd be like, oh yeah, that has to go underneath. That it has to have a whole number exponent. Negative 1 is not a whole number, right? Whole numbers are positive. So that's why this does not work. Okay, and then 4 to the a power, why is that not a monomial? A monomial cannot have a variable exponent. Right? What kind of exponent can it have? A whole number exponent. Okay, a is not a whole number. We don't know what a is. A could be a half, right? That's not a whole number. So it cannot have a variable as an exponent. And and then this comes back to what we kind of talked about up here on the second one, is the variable must have a whole number exponent. Okay, so make sure you write these down. Oh, let me explain that one more time. Remember, -1 is not a whole number. -1 is an integer. Whole numbers are positive counting numbers, like 1, 2, 3, 4, 5. Okay, and then integers are when you add in the negatives. So that is not a whole number. But what I was going to say a second ago is pause it and make sure you write down these answers, because there's going to be a section on your homework where you have to tell me, is this a monomial? Why or why not? I believe that's on your homework. I said that. It's still, you got to write it down. So pause it if you need to, write that down, and then keep going. Okay, some more new words. A polynomial is a monomial or a sum of monomials, each called a term of the polynomial. Okay, so a polynomial is one of these, or the sum of more than one of these, okay, that are each called a term in the polynomial. The degree of the so let's, you know what, let's do this kind of, let me think. No, we'll do this, we'll talk through this whole thing. So the degree of the polynomial is the greatest degree of its terms. And then when a polynomial is written so that the exponents of a variable decreased from left to right, we call that descending order. The coefficient of the first term is called the leading coefficient. Okay, so let's kind of talk about some of this vocabulary here. So this entire big old thing, this is a polynomial, right? It's a polynomial. This is a monomial, this is a monomial, this is a monomial, this is a monomial. Okay, I'm adding them together, therefore, this is a polynomial. And if you were like, but what? There's subtraction, you're not really adding it. Yes, because that's the same as adding a negative, right? Subtraction is adding the opposite. So this is a polynomial because it is the sum of monomials. Monomial, 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 monomial. We add them together, that makes a polynomial. So now we have to talk about a couple different things. First is, what are the degrees of each of the terms? Okay, what would be the degree of each of the terms? Well, this would be the degree, right? Is this the biggest exponent? Yes, so the degree of my polynomial is 3. Because this is my biggest exponent, this number that's in front of it is what we call the leading coefficient. It's leading the way, it has the biggest exponent, right? It's not the biggest coefficient, right? This is a 2 over here. Well, that's not even a coefficient. Well, I guess technically it is. But it's in the lead because it has the biggest degree. And then, let's see. Oh, this number here at the end is what we call a constant. Okay, it doesn't have a variable with it, it's constant, right? This kind of depends on whatever x is. 12 is constant, it's always 12. There's no variable with it, it's constant. So let's look down here to do some examples. Number 1. It says, write 15 minus x to the third plus 3 in descending order. Identify the degree and the leading coefficient of the polynomial. Okay, so when we're looking, what's the biggest exponent that you see? X to the third. Okay, here's where you have to kind of keep in mind what we've been doing all year long. What symbol is in front of this? A minus sign, right? That's like saying adding negative. So if I were going to write this, it would be negative x to the third, okay? And then I can actually, you know what? It's fine. And then I can do 15 plus 3 is 18. So that would be my polynomial written in descending order. So the degree of my polynomial is 3, because my biggest exponent is 3, and it's written in descending order. And my leading coefficient, what number would go in front of the x to the third? It's -1, right? I have -1x to the third. Okay, turn it over. Let's do number 2. Write 5y minus 2y squared plus 9 in descending order. So the highest exponent that I see is squared. So it's -2y squared. Okay, and sometimes what I like to do is I'm like, okay, I've taken care of that guy, right? I don't want to leave anyone out. Then I have 5y. It's positive. And then I have plus 9. It is in descending order, correct? I have y squared, y to the first, and then no y's. So what's the degree? 2, right? The degree of my polynomial is the biggest exponent. And then my leading coefficient, -2, because it's -2y squared. So why don't y'all try number 3 on your own, try to write it in descending order, and then we'll come back and check your work. Okay, on number 3, I can recognize that the biggest exponent that I have is this x to the 4th. So that's -2 x to the 4th. Okay, there are no x cubes, right? No x to the thirds, but then I have 17 x to the 2nd. Okay, and then let's look at this. It's kind of tricky. I have -3 and -8x. How many x's is that all together? -11x plus 12. This is the polynomial written in descending order. Okay, I took -3 and -8 to get -11x. Okay, and you don't square it because we're not multiplying exponents together, right? We're not multiplying -3 times -8. We're just combining. So the degree of your polynomial would have been 4, and the leading coefficient would have been -2 again, because that is the first one. Okay, so there's a couple special kinds of polynomials that we're going to talk about. A polynomial with 2 terms is called a binomial, just like bicycle, right? Oh, did I skip that? No, there we go. Has 2 wheels, right? Bi means 2. So if it has 2 terms, it's called a binomial. If it has 3 terms, it's called a trinomial. So it says, tell whether the expression is a polynomial. If it is a polynomial, find its degree and classify it by the number of terms. Otherwise, tell why it is not a polynomial. Okay, so number 9, or the number 9. Is it a polynomial? If you need to, flip your page over. Right, the definition is a monomial or the sum of monomials. So is the number 9 a polynomial? Yes, because it's a monomial, right? It can just be one monomial, and 9 is a monomial. So the degree is just 0, right? Oh, and then we have to also classify it, so that's a monomial. Right, it's one term. It has a degree of 0 because there's no variable with an exponent on it. Okay, what about 2x squared plus x minus 5? Is that an exponent, or is that a polynomial? Yes, it is a polynomial. It's 3 monomials being added together. So let's find the degree. What's the degree of it? It's the biggest exponent, so that's 2. And how many terms is it? 3. So that is a trinomial. Okay, and then I messed up. We're going to change this, and we're going to make it 8 to the n power. I just didn't superscript that guy. So make it 6n to the 4th minus 8 to the n. Is that a polynomial? No. Okay, it is not a polynomial because it has a variable exponent, right? I'm trying to give you a couple examples that are no. We talked about it on the front. This is not a monomial because it doesn't have a whole number exponent. We don't know what n is. N could be a decimal for all we know, right? It's a variable, not allowed. So it is not a polynomial. So because it's not, we can't do any of that. What about n to the negative 2 minus 3? No. Right? It has a negative exponent. Not allowed. Right? So if you look at the front, right here, we talked about it. It must have a whole number exponent. It can't be a negative. So therefore, this is not a monomial. And if this is not a monomial, this cannot be a polynomial, because a polynomial is the sum of monomials. Okay, last one. 7bc to the third plus 4b to the fourth c. Is that a polynomial? Is this a monomial? Yes. Is this a monomial? Yes. Is this the sum of two or more or monomials? Yes. Therefore, it is a polynomial. How many things are we adding together? 1, 2. So it is a binomial. And if we're looking for the degree, okay, oh, this is fun. This is the first time we've encountered this. Okay, let's talk about it. So here, what would be the degree of this monomial? This is a 1, this is a 3. So this has a degree of 4. This is 4 plus 1. What's 4 plus 1? 5. So what would be the bigger degree? This guy, right? So it has a degree of 5 because, again, you flip over to the front. The degree of a polynomial is the greatest degree of its terms. The degree of a monomial is the sum of the exponents of the variables in the monomial. So 4 plus 1 is 5. Okay, last example. It says, tell whether the expression is a polynomial. If it is a polynomial, find its degree and classify it by the number of its terms. Otherwise, tell why it is not a polynomial. So what do you think? Is that a polynomial, yes or no? What do you think? Yes, it is a polynomial. So what would be the degree of it? The degree would be 4 because that's the biggest exponent, right? And then I'm going to classify it. It's 1, 2, 3 terms. So it is a trinomial.